Welcome back to Advent of Code. Today is the last day of Advent of Code 2020. We are working on the day 25, and before starting I just want to thank you so much for the support in this series. So don't forget to drop a like in this last episode, and also don't hesitate to drop a comment if you have some specific things that you want to see on this channel. I'm still debating exactly what's next video I'm gonna create. And let's dive right in this day 25. So day 25, we have really good news. We finally arrived at the destination that we wanted to arrive. This is super relieving. However, we have some trouble with the key to enter our specific room. And we have a specific handshake that is done, and we need to crack this handshake. This is the only way to get into our room without climbing the stairs down and back up. So in there we have two different things that happens. First of all, you know what, we need the input, and I'm just gonna grab the puzzle. No, we actually have here a specific input. That's all we need. So the actual input is consisting in those two keys. So here, this is one of the input that we're going to paste in our test case scenario, and this is the second input, I believe. Yes, this is the door public. This is the card public key, so we're going to paste that first, and then this is the door public key. So these are the two things that we know at the beginning. We know these public keys, and we know that actually we're going to create a function, you know, this specific thing that takes a specific subject number. So we're going to call that function get in. What is it? We need to get it transforms the subject number. We have this value that is very specific. Constant. Should we call that key, or let's call that divider, just to make sure this is clear. So here we need the subject, and we need the turns. How many turns is it happening? Because we know that this is the thing that we need to do. Get the value to itself multiplied by the subject number. And the subject number starts with 1, then a number of times. So actually, I thought this was quite trivial, but there is a bit of complexity here. We have 1, and I believe that once we need to multiply 1 by the subject number. So actually, instead of doing this function, you know, what I want to do, I want to create something called a rainbow table, which is something that is done to attack a specific hashing, cryptographic hashing. So let's call that rainbow table, and we're going to use a map. Are we doing a map? Because we need for a specific value to get, okay, so no, actually we need a rainbow table. We need 2 rainbow tables. So rainbow table, oh, we need several rainbow tables. Oh my god, this is confusing, I'm sorry. So let's just do 1 rainbow table. They're gonna be here the value, the subject, and we're gonna be using this subject. First of all, we're gonna make this like really simple at first, and we push rainbow table of 0 equal to 1, and then we're gonna do a for loop between 0 and let's say 10,000. We do rainbow table.push. Actually, you know what? This rainbow table, let's create an array of 10,000. 10,001. Because we have 0, actually. Zero up to 10,000. This means 10,001 object in the array. So here we're gonna push rainbow table of I minus 1 times the subject, and this is gonna be divided, or modulo divider here. I believe this is what happens on the first turn. Oh, you know what? We might be doing an off by 1 error somewhere around here. That's not a problem. And actually, instead of 10,000 for now, we're just gonna run like 10 turns. Let's say const max turns equal 10. So this array is going to be max turn plus 1. We're going to make something very clean. That's the goal. So here we're going to log at last the rainbow table. Day, hola, there are so many days being displayed here. That's beautiful. Not a number. Oops. Not cool. So we're gonna fill that with ones just to clean these. Okay, so I have made something very bad here. Oh, not dot push, sorry. Rainbow table of I equal this specific thing. Okay, now I think we've got something good. My bad. I can remove the fill now. And we have something clean. So what happens is that I initialize an array that has empty values. We don't care about them. And then we do these multiplications. Now what I want to check, we've taken this subject, which is 57. This is this object. We say the initial subject number of 7 with a loop size of 8. So I think the problem is subject number of 7. Okay, so this is always, the subject number is always 7. So that's, subject is always 7. This is a given. In that case, I don't understand. Okay, we have the subject and we need to multiply by this by the private key, right? This is interesting. This is a bit challenging. What is 7? Does that mean that I don't think this is the code that I've written here is correct here. Let's see. Okay, so this produces this public key number. Oh, that is, I made some mistakes here. The thing is, this is the public key and the subject key is always 7. So there will be only one rainbow table, and here we are doing the right computation. Yes, that is correct. That's good. Now we just need to do const turn equal rainbow table dot index of this number. So we have computed the rainbow table here with this subject and the divider, and now we just need to take the index of this number. This should give us how many turns we need to compute this public key, the card public key. So yeah, what's really cool with this approach is that here we have like computed everything. So we could put like 10,000 values here. That's going to be super quick to compute. And then here we can find the turn for the card, how many turns we needed for the card, how many turns we needed for the door. For the door, this is the public key. So we start from the public key, which is something that everyone knows about, and we end with the secret key. The secret key is the number of turns. That's something that no one should know about. And we have 8 for the first value and 11 for the second value. So we are good here. What we're gonna do now is we're gonna use these things in here. I think that's correct. So now we're gonna be using this input. So we need to map x of parse int of x. So those two numbers becomes an array of 2 numbers. So let's say here door public key and card public key. Is that in the right order? We don't really care about that. We don't really care about the order, I believe. So now we have 11 and 8. That is good. What do we need to do with that? So basically here we are able to get this the loop size, and the loop size is something that is secret. And here we need to calculate the encryption key. So the loop size with the other device public key to calculate the encryption key. Okay, so that's easy to do. We just have to do card turn times door public key, and that is going to be our encryption key. Thanks to math. The cool stuff is that here you can multiply card turn by door public key or door turn by card public key. No. I'm doing something bad here. We multiply that's interesting. I really need to be focused here. Had some great Christmas lunch today. It was great Christmas dinner as well. I hope you had some great time today. So we need to transform the number with a loop size of 8. Okay, so that's another subject number. Okay. So basically here we're creating a rainbow table, and now we're gonna need to do something else. Get or transform subject and turns, and basically here we need to do something similar to that here. So let value equal 1, and here between 1 and turns we need to do value equal value times subject modulo divider. So what I'm doing here is that I'm careful to do this rainbow table just once. So if I call this function for turn 1, turn 2, this is going to be like a terrible complexity. So instead we're doing this, I think this is kind of dynamic programming, because we store all of the stuff, we use tabulation to store all of the stuff inside an array, and here we just do this transform once. So the transform, we need to do transform of the subject here is a door public key, and the turns is card turns. So now I believe we have the correct encryption key for our test scenario. Let's see. Yes, that is correct. This is perfect. So now we can actually use our full input. And just for fun, we're also going to be logging here the card turn, just to see how many turns we needed. Oh, -1. Okay, so it means that most likely we need more than 10,000 turns here. So you know what? We're going to put 10 million turns here, and that would make a lot of sense. This is still -1. Am I using the right way to go here? I don't know. I might not be using the right way to compute this. Okay, here we are using 100 million turns, and it is interesting because the value was 11 million turns, which give us this specific encryption key, and I believe this is gonna be the right one. Yes, we are good. Let's go to part 2, and from what I've read, part 2 is basically not an actual problem. It is just, you have to just complete and get the gold stars for all of the other problems. I still have 2 more gold stars to capture, so I won't be able to show you the final reveal. So yeah, this is it for this series. I had a ton of fun. I still had some problems on part 2 of day 20 and part 2 on day 23. Wait, 20 and 23, yeah, that's it. Yeah, thank you so much for being around, for doing a lot of support with your comments, your subscriptions, and your likes. It really helped me a lot. So thank you very much for that. And one more time, don't forget to drop if you have some ideas on what you want to see next on this channel. I believe I'm going to be doing some short tech talks to discuss some tech news and help you stay on top of everything that's happening in the world with some like short tutorials basically. Yeah, that's what I want to do, but I'm not sure exactly how it's gonna look like. Anyway, I'm gonna stop rambling now. Thank you so much for the support, and see you in another video. Bye bye.